Hello, everyone, and welcome to the lecture on Amazon Bedrock Knowledge Bases. So, this lecture will contain all these topics: RAG and Amazon Bedrock Knowledge Bases. With Amazon Bedrock knowledge Bases, you can set up a knowledge base, pre processing unstructured data, vector embeddings, floating point numbers, float 32, or binary numbers, runtime execution, unstructured data type supported, vector stores supported, data ingestion into knowledge base, structured data supported. So first topic is RAG and Amazon Bedrock knowledge bases. So foundational models possess broad general knowledge, but their responses can be further enhanced using retrieval augmented generation, also known as RAG. Retrieval augmented generation is a technique that uses information from data sources to improve the relevancy and accuracy of generated responses, resulting in enhanced outputs. Amazon Bedrock knowledge bases enables integration of proprietary information into generative AI applications, enhancing their capabilities with organization-specific data. When a query is made to a knowledge base, it searches through your data to find relevant information that can answer the query. The retrieved information is then utilized to improve the quality and accuracy of the generated responses. Users can build their own RAG-based applications by leveraging the capabilities of Amazon Bedrock knowledge bases to create custom solutions. And the next topic is with Amazon Bedrock knowledge bases, you can. So I'll list out the tasks that you can do with knowledge bases. So first is answer user queries by directly retrieving and returning relevant information from data sources. Next, you can utilize retrieved data to support the generation of accurate and relevant model responses. It can augment user-defined prompts by integrating relevant information fetched from the knowledge base. Include citations in generated responses to verify accuracy and reference original data sources. Process documents containing visual resources to extract images and generate insights based on the visual data. Converts natural language inputs into customized queries such as SQL to retrieve information from structured data stores. Enables immediate access to new information by directly ingesting updates from data sources. Employs re-ranking models to optimize and influence the relevance of retrieved search results. Integrates the knowledge base capabilities directly into Amazon Bedrock agents workflows. Set up a knowledge base. So I'll talk about how to set up a knowledge base. So first step is if you are connecting to an unstructured data source, you may optionally set up your own supported vector store to index vector embeddings. This step can be skipped if you use Amazon Bedrock console to create an Amazon OpenSearch serverless vector store. Then you connect your knowledge base to either an unstructured or structured data source. Then next you sync your data source with your knowledge base to ensure up-to-date information. Then you set up your application or agent to perform specific actions, and these are: you can query the knowledge base and return relevant sources. You can query the knowledge base and generate natural language responses based on the retrieved results. If connecting to a structured data store, you can transform a query into a structured data language specific query such as SQL. Next topic is pre-processing unstructured data. To enable effective retrieval from unstructured private data, the common practice is to convert the data into text and split into manageable pieces to ensure better processing. These pieces or chunks are then converted into embeddings and returned to vector index while carefully maintaining a mapping to the original document. These embeddings are subsequently used to determine semantic similarity between incoming queries and the text derived from the data sources. Vector embeddings are structured as a series of numbers representing each text chunk. A model converts the text into these vectors to allow for mathematical comparison. These vectors can exist as either floating point numbers, float 32, or binary numbers, though most embedding models supported by Amazon Bedrock use floating point vectors by default. If you choose to use a binary embedding model, you must ensure that you also choose a corresponding model and vector store that specifically supports binary vectors. Regarding comparison, binary vectors use only 1 bit per dimension, making them less costly on storage than 32-bit floating point vectors, though they are not as precise in their text representation. So this is an example of float 32 or binary representation. So for example, let's say you have some text. Amazon Bedrock uses high performing foundational models for leading AI companies and Amazon. So each word, so I'll take the example of binary because it's easy. So each word will be either 1 or 0. And this is the whole array. So as you can see, it's very rough. It's not very fine grained. And so every word either has to be 1 or 0. So the comparison may not, if you are searching for something, it may not be accurate. But in the floating point vector representation, you will have a very high range. It can have negative and positive, and this will accurately depict each and every word in your corpus of text. So this is an example. Let's say you are searching for smartphone, and imagine you have 3 documents in your database. You have iPhone 15 review, Android Galaxy review, landline telephone manual. And if you are using, so this is mostly used most of the time. So this is the default float 32, which has a high precision. The AI calculates the distance between the query smartphone and the documents perfectly. It knows iPhone is extremely close. So that will have a, let's say the vector embedding is 0.002. It knows the Android is extremely close, distance is 0.003. It knows the landline is distinct and far away. So let's say it has a representation of 0.500. So result, it can distinguish that iPhone and Android are essentially tied but slightly different. So it can identify or correctly depict what is closer, whether there is an exact match or not. But let's say with binary, which has a low precision, the AI creates a simpler map. It sees iPhone and Android as just phones, and probably they will have a value of 0. And this creates a collision where it cannot mathematically distinguish which one is better match because it threw away the decimal points that held the fine detail. Next topic is runtime execution. At runtime, an embedding model is used to convert the user's query into a vector representation. So during runtime, what will be the response? So this will be happen at the runtime. So what we have seen is how we store the data. Now what will happen at the runtime? The system queries the vector index to find text chunks that are semantically similar by comparing the document vectors to the user's query vector. In the final step, the user's original prompt is augmented with the additional context retrieved from the chunks found in the vector index. This augmented prompt, combining the user's question and the new context, is sent to the model to generate a final response for the user. This process illustrates how retrieval augmented generation operates at runtime to effectively augment responses to user queries. Next topic is unstructured data stores supported. So these are the support for unstructured data stores. So these are S3, Amazon S3, and rest all is in preview, but they will be coming. Confluence, Microsoft SharePoint, Salesforce, web crawlers, and custom data source. Next is vector stores supported. So this is where we support the vector embeddings. And these are Amazon OpenSearch Serverless, Amazon Neptune, Amazon Aurora RDS, Pinecone, Redis Enterprise Cloud, MongoDB Atlas. Next topic is data ingestion into the knowledge base. The process of converting your data into vector embeddings is called ingestion. The ingestion process that turns your data into a knowledge base involves the following steps. First step is the data is parsed by your chosen parser. Each document in your data source is split into chunks subdivisions of the data that can be defined by the number of tokens and other parameters. Your chosen embedding model converts the data into vector embeddings. The vector embeddings are written to a vector index in your chosen vector store. After the ingestion process is complete, your knowledge base is ready to be queried. If you make changes to a data source, you must sync the changes to ingest additions, modifications, and deletions into the knowledge base. Some data sources support direct ingestion or deletion of files into the knowledge base, and this eliminates the need to treat data source modification and ingestion as a separate step and the need to always perform full syncs. Structured data type supported. So these are the structured data types supported. So there are only two: Amazon Redshift and AWS Glue data catalog, which is through AWS Lake Formation. And that's all. Thanks for watching.